Hello, it's time for some algebra. Welcome to video 3C. And in this video, we're going to talk about expansion boxes. Expansion boxes are a way of using geometry to kind of understand the distributive property. It's also known as the area model for multiplication, and that's something that comes up later in algebra. So it's kind of good to see it now, and it helps a number of people to distribute correctly. So let's see what it is. To introduce it, we're going to talk about the following geometry problem. So we have two smaller rectangles that are combined into a larger rectangle. And our goal is to find the total area of the figure below. So we could find the area of this first rectangle. Its length is 9 and its width is 6, so 9 times 6 is 54. This smaller rectangle is 4 by 6, and 4 times 6 is 24. So I have the area of the two pieces, and if we add those up, we get a total area of, looks like 78. Now, that's one way of doing it. We could have also taken like a little shortcut and combined these two. The total length of the whole rectangle is 9 plus 4, which is 13. If we multiply that by the width here, 13 times 6 is also 78. So there are two ways, at least we could have gotten this result. All right, let's try this one. I'll find the way, all the individual pieces first and then add them up. So 6 times 5 is 30. This is 5 here too, so 3 times 5 is 15. And 2 times 5 is 10. So I have all the pieces. And now if I add them up, 30 plus 15 is 45, plus 10 more is 55. Okay, again, I could have just taken the total kind of length here times the width. The total length here is 6 plus 3 plus 2, that's 11. 11 times 5 is 55. All right, so we got it two different ways. The fact that we can get the area two different ways is kind of key to understanding expansion boxes. So on here, the first way, I'm going to find the individual pieces. Now this time we have a variable, but still the area is width times length, so 6 times x is 6x. That's the area of this first piece. The second piece, 6 times 3 is 18. So the first way is just by finding the pieces and adding them up. 6x plus 18. The other way we could have found the area is taking the width, 6, times the total length. It's another way of finding the area of the big rectangle. The total length is x plus 3, and I need parentheses around that because we're doing 6 times that whole length. So both of these expressions equal the same thing. They're both equal to the total area of the figure. So they have to be equal. So we get that 6 times the quantity x plus 3 equals 6x plus 18. That's just the distributive property, right? 6 times x and 6 times 3 is 6x plus 18. Turns out distributive property makes sense in geometry too, not just algebra. Okay, so the area the first way, 7 times 4x, well, 7 times 4 is 28. And then still times x, so 28x. 7 times 3 is 21. So if we add these together, we get 28x plus 21. Right, the other way would be to take the width times the total length, 4x plus 3. These two expressions have to be equal. So 7 times 4x plus 3 had better be equal to 28x plus 21. And it is. Okay. We may have more than just two rectangles. Here we have three pieces. This first one is 6 times x squared. So that's 6x squared. That's the area of that piece. 6 times 3x. Well, 6 times 3 is 18. And we're still multiplying that by x. 6 times 5 is 30. So here's the fact. 6 times the total length, x squared plus 3x plus 5, has to equal what we get when we add up the area of each piece. Has to equal 6x squared plus 18x plus 30. So we see 6 times x squared is 6x squared. 6 times 3x is 18x. 6 times 5 is 30. Yeah, that's the distributive property. Okay, so we're going to use expansion boxes to do this one. All right, so we have the expression 4 times x plus 13. Well, we're going to take this to be the width of the rectangle and this to be the length. So I'm going to put a 4 here, I'm going to put an x here, and a 13 here. The total area would be 4 times x plus 13. We just got to find the area the other way. So by adding up the pieces. So this would be 4x. 4 times 13 is 52. So 4 times the quantity x plus 13 should equal 4x plus 52. Okay, let's try this one. -2, that's the width. It's okay to have a negative width. We're kind of using this for algebra. This would be x squared. Let's make this minus 4x, and this plus 9. So we just have to kind of complete the boxes. So this would be -2x squared. -2 times -4 is +8, and we have an x. -2 times 9 is -18. I think sometimes people like the boxes because it makes it very clear, kind of just fill out each box. It kind of makes it simple for them. And it helps them get the signs correct. So if that helps, wonderful. So this is equal to -2x squared plus 8x minus 18. Okay, let's do a couple more examples. We have 4 times the quantity 5x minus 6. So I'm going to put a 4 here. And a 5x minus 6 there. So, okay, let's find the area the other way. 4 times 5x is 20x. 4 times -6 is -24. So this is equal to 20x minus 24. Here we have -2 and 3x minus 7. So we're going to multiply -2 times 3x and -2 times -7. Both of these getting multiplied by -2. So we have -6x. -2 times -7 is +14. This is -6x plus 14. Okay, couple last examples. So let's use the distributive property here to do this. So we could draw a box. If you like the boxes, they're good. They're going to help, like say, help us later in algebra. So this is 2, and this is x and 17. We see that we're going to get 2x. 2 times 17 is 34. So plus 34. All right, on this one, we're multiplying one thing times two things. That's why I have 2 boxes here. So this is going to be 3. We have 5x and a minus 9. This is going to give us 15x. And 3 times -9 is -27, so minus 27. So if you're asking yourself, do I have to use boxes when I do distributing? No, not at all. But sometimes they help people. And the area model is an important concept to understand. That's a good way of explaining why the distributive property has to be true. Okay, on this one, this is tricky. They wanted us to go backwards. So what can we multiply to get 4x plus 36? Well, 4 goes into both of these. So I think I could write this as 4 times something. So 4 times x is 4x, and 4 times 9 is 36. So we're supposed to come up with some sort of multiplication that ended up being 4x plus 36. I think that's how we can do that. That's kind of going backwards. I want to say undistributing, but it's still the distributing property. It's just going the other way. All right, more about that later. This is your journal assignment. So if you want to do these problems and show your teacher that you understand this, that's always good. Good luck and everything.